Let's talk about surface tension for a moment. So, surface tension is a phenomenon in which the surface of a liquid seems to have a tension, and so it tends to act something like a film, which is to say that it basically resists forces that would deform the shape of the surface of a liquid or a film. Now, this is a consequence of the fact that molecules in a liquid have cohesive or attractive forces for each other. And since molecules are attracted to each other, they seem to behave as if they wish to maximize the attractive interactions and minimize the number of molecules that are left on the surface of the liquid, like these molecules right here, these surface molecules. So these molecules on the inside experience attractive interactions to other molecules around them, but these molecules on the outside experience only attractive interactions that tend to pull them to the interior bulk of the fluid. And so the overall result here is that molecules on the outside of the fluid tend to be pulled inward, and that sort of gives the fluid surface something that behaves very much like a tension, and it tends to exert a net force that pulls inward on the fluid. And because fluids wish to maximize the amount of molecules that can benefit from all these attractive forces on the inside of the portion of the fluid and minimize the surface area, they tend to adopt a spherical or a hemispherical shape because the sphere actually maximizes the amount of volume to surface area. And so up here, if we see this drop of oil, that's oil, and this is water. This is from our lecture notes. The surface of the water is resisting the force of the oil bead, pushing down against it by pushing back up against the oil bead. If we were to look at surface tension in terms of a film, what we'd find if we look very closely is that the film actually has a top surface and a bottom surface, and it actually has liquid in between the surfaces. So there are molecules on the top here, and there are molecules on the bottom. And this film, although it looks very, very thin to the eye, it actually has some liquid in the middle, which has all these attractive interactions, and a top and bottom surface that tend to resist change to the shape of the film on the top and bottom surfaces. So if we were to say that a film exerts a force, which, as we know, would be equal to the mass times acceleration of an object, like here there's this bar that's being held in place, so it would be the mass of the bar times the acceleration of the bar. This would be equal to 2 times gamma times length, because the force that is exerted by a film is directly proportional to the length of the film. That's why we have the term L here. And we have the term 2, the factor of 2, because this represents the top and bottom surfaces of the film. Now, if we look very closely, we find that gamma, this term that represents the amount of surface tension, actually has units of newtons per meter. So it is sort of gamma isn't directly a term that represents tension. It is actually a term that gives us an amount of force or tension in terms of length. So gamma would be equal to ma over 2L if we were to rearrange this formula, which, as you can see, ma comes out to units of newtons, and 2 times the length of the film gives us units of meters. Now, if we were to look even closer at this, if we said gamma is equal to an amount of newtons over meters, if we represent the newton as just the kilogram meter per second squared, and we carry over our meters, we find that our meters drop out, and we're left with units of kilograms per second squared. And so ask yourself, where else can I find kilograms per second squared? The answer is that this is actually the same set of units as if we had a measure of joules, or energy, per area. And that's just because the joule is a kilogram meter squared per second squared. And if we had to carry over our meters squared, and they canceled, that would give us units of kilogram per second squared. So all of this is just to say that gamma gives us units of tension or force over length, or energy per unit area.